So, students, we are discussing this low frequency AC analysis with CE, that is emitter bypass capacitor. You can see with emitter bypass capacitor. So we need to plot this AC analysis. So we need an AC equivalent circuit. So what is AC equivalent circuit? Consider only AC. Then don't consider DC. Capacitor should be short circuit. That means in AC analysis, consider only AC. DC source ഉണ്ടെങ്കിൽ നമ്മൾ അതിനെ കൺസിഡർ ചെയ്യരുത് അല്ലെങ്കിൽ ഷോർട്ട് സർക്യൂട്ട് ചെയ്യണം. കപ്പാസിറ്ററിനെ കൺസിഡർ ചെയ്യണം, കപ്പാസിറ്റർ അതിനെ ഷോർട്ട് സർക്യൂട്ട് ആക്കണം. So this is a capacitor. So this is short circuit. So there is no capacitor, it is short circuit. Here there is no capacitor, that is short circuit. Here there is no capacitor, that is short circuit. Then I already told that here we are using a constant current biasing. The last video I expressed that this is a constant current bias circuit. Then I am drawing the circuit over here. So E figure, that is base, emitter, collector. So this this is hybrid pi model, or this transistor is replaced by an equivalent model here, that you can see this in hybrid R pi, GMV pi, RO, this base, collector and emitter. This is hybrid pi model. Then we'll start from the base terminal. Base terminal, you can see this is the base terminal. Base terminal, there are two resistors, RB and R signal. Towards R signal, V signal is connected. Okay, this capacitor is short circuit, so we doesn't need to consider. So to the base, there is RB resistance, there is R signal and V signal. Then connecting the emitter, this terminal have to be checked. That means this have to be used. Either less resistance path, so the open short circuit path, that is short circuit. Then collector. Towards the collector, water connections are there. RC and this is DC. This have to be grounded. Either short circuit so RL. So either already existing RO, or we can make it like a neglect or open circuit. We doesn't need to consider this. So remaining to the collector, we have this RC grounded, RL also grounded. So this is the AC equivalent circuit. Then adinathu oru point need to be clear, somewhat clarity have to be there. That means we have one signal here, V signal. Then I am connecting an R signal here. Signal constant, that is the resistance that is support towards this signal, voltage signal. And then after that there is one RB. And then we have this R pi. So what I told is the input voltage, this is not the input voltage, the signal is the input voltage. So we will consider one voltage that is input voltage, that is VI. So VI is the voltage. നമ്മൾ ഇപ്പോൾ ഇവിടെ ഒരു 10 വോൾട്ട് കൊടുത്തു. Suppose I am giving a 10 volt here. ഇവിടെ ഒരു ഡ്രോപ്പ് വരുന്നു 1 volt. That remaining 9 volt is coming at this point. That means after the drop across this R signal, I will get some voltage. That voltage is called VI. That R pi across the voltage, that is, that this is V pi. So V pi and VI are parallel. So I can say that input voltage will be the voltage that is V pi. And a parallel connection. Our point and need to be clear. So I am giving you some signal voltage. Some drop is there across R. After the drop, I will get an voltage. That is voltage is called signal voltage. So that signal or that input voltage is the voltage at this point. That means after the R signal, I will get one voltage that is called VI, input voltage. So please note that point. How I can get this input voltage? This is the voltage that is after the signal voltage. Let me clear the screen. So I doesn't need this diagram. This diagram I can remove. We have this we need only this diagram. This diagram can be removed. We need only this diagram. Okay. So first of all, I told that we need that input impedance. What is input impedance? Please note that one point. Input impedance is taken only after the R signal. R sig in the parayuna R resistance കഴിഞ്ഞതിന് ശേഷം മാത്രമുള്ളതായിരിക്കും impedance. So after this R sig, we are calculating this input resistance. So this ഇങ്ങോട്ട് ഈ R sig കഴിഞ്ഞ് ഉള്ള resistance. So what all resistance are there? RB and R pi. How they are connected? Parallel. So I can say that input impedance will be equal RB parallel R pi. And ഇത് വളരെ നമുക്കറിയാം R pi എന്ന് പറയുന്നത് വളരെ ചെറിയ റെസിസ്റ്റൻസ് ആണ്. പാരലൽ കണക്ഷൻ എടുക്കുമ്പോൾ this input impedance can be equated like R pi. So actually it is RB plus RB parallel R pi, but R pi വളരെ small ആണ്. Then we can equate it as R pi. Then what about output impedance? That means please note that output impedance will be taken before R. Please note that output impedance that is taken before R. RL ന് മുന്നേ. That is അതാണ് ഈ ഒരു RO യുടെ ഒരു relevance. Output impedance is taken before RL. So what all resistance? Either number doesn't need to consider. I told that this RO doesn't need to consider. So only resistance that is coming, that is only RC before R. So output impedance that is RC. I think you got the idea regarding this input impedance and output impedance. Let me clear the section. Okay. The next is I need to take voltage gain, simple voltage gain, or we will call it as voltage gain. Voltage gain, that is AV, voltage gain. So that is equal output voltage divided by input voltage, not signal voltage. I told that there is one voltage that is after this, that is the voltage at this point. It is called V input voltage. And output voltage you can take, this is the output voltage, this is the output voltage. So we have three voltages, that is signal voltage, input voltage, that is the voltage after the R sig, and we have one output voltage. So this voltage again is taken from with respect to this VI, that is the voltage that is after the R signal, and V out. Then output voltage. Output voltage is what simply we know that is how current into resistance. What is the current here? I told that there is one current that is IC, small IC. You check that. Number current direction, it is direct opposite. But we are taking the current across this RL, but current is going away from that. So we need a negative sign. Then what is a current? Small IC. What is the resistance there? This resistance doesn't need to consider. So we have RC and RL. Output voltage is the voltage across this point. So we can consider these two resistance, both parallel. So I can say that this is RC parallel RL. Output voltage. Then what is the small IC? We already, negative sign is there. We already know that this is GM into V pi, that we already discussed this point. Into RC parallel R pi. Then E negative. So if you are taking this output voltage, we have this negative sign. Negative sign relevance is we have 180-degree phase shift. So that is a single stage RC coupled amplifier that will provide a 180-degree phase shift. This negative that indicates that this is providing a 180-degree phase shift. Then what about this is output voltage? What about input voltage? Input voltage, you know that this input voltage is parallel to this voltage. This two voltages parallel. So I can say that input voltage equal to V pi. So I can state that the voltage gain, that is V0 by Vi, equal output voltage is minus Gm V pi into RC parallel RL divided by what is input voltage? V pi. This V pi cancel, so I can get minus Gm into RC parallel RI. This is the voltage gain. This voltage gain is considering not with respect to signal, this input voltage and this output voltage. That is voltage gain AV. Then we can take one point over here. What is the open voltage? Open circuit. That means voltage gain at RL equal to infinity. We can consider that value will be equal to like this RL will be infinity, then I will get like minus Gm into RC. If RL is infinity, I will get like this. This is a condition. This is a case. From this, we can deduce one condition like this. This is called voltage gain. Next we have one more gain that is called overall gain. So from the word itself, we can say that something is overall. Overall gain means overall output divided by overall input. What is overall input? It is not Vi here. This is V signal. So we need to take a fraction like this. Output voltage divided by signal voltage. And this factor, this V signal can be written like VO by Vi into Vi by V signal. So factor can be rewritten like this. The Vi cancel, again we will get VO. So this factor we already reduced, that is AB. So we need to find what is Vi divided by V signal. For that, I am drawing one diagram. This diagram you already know. I will give the relevance of this diagram. I am plotting two resistance over here. This total voltage, that is V signal, and this is R signal, and this is R input. I think you got the idea. And this is ground, and this voltage is V input. E oru portion de oru where style V signal and R signal. After that, there is one voltage that is R input, V input, and that is R input. We can say that this voltage, that means the total with the input resistance item mentioned here. So what will be V input or Vi? Vi will be from that voltage division rule. I can write it is V signal into R input divided by R input plus R signal. And what is this R input? We already reduced input impedance, that is R pi. This is R pi. So I can write Vi, that must be equal V signal into R pi divided by R pi plus R signal. So overall gain I can write. What is overall gain? This V output by V signal equal, what is this AB? We already reduced that. It's minus Gm into RC parallel R. This term. Okay. Into what is Vi by V signal? This term. So from this term, what will be Vi by V signal? This term can be brought down here. That is V sig here. So there is no term here. That is R pi divided by R pi plus R signal. So like this, R pi divided by R pi plus R signal. This is the overall gain. So this term, that is V output by V signal, that is the overall gain, that is minus Gm RC parallel RL into R pi divided by R pi plus R signal. This is the overall gain. So let me conclude the section. So we discussed this low frequency AC analysis with CE, emitter bypass capacitor, and we reduced first input impedance, that is RB parallel R pi, and we can write almost equal R pi. Output impedance, that is RC, then voltage gain, that is minus Gm into RC parallel RL, and then overall gain, that is GV, overall gain, that is equal minus Gm RC parallel RL into R pi divided by R pi plus R signal. So these are the first part of derivation from the second module. Very important derivation. So please go through, and if you have any doubts, you can contact me back. Okay, thank you.